So we've been looking at the scientific notation stuff. I want to make sure you guys are clear on how all of it works before we do a quiz. So first, let's have you convert to scientific notation. So I'm going to have you quickly convert those two in your notes to scientific notation. So for the first one, remember it's all about, the focus is on that first non-zero digit. So here the first non-zero digit's the 8, so it becomes 8.4 times 10 to the -5. Good. Remember, if we're looking at place values, this is -1, -2, -3, -4, -5. That's in the 10 to the -5th place value. Or the decimal has to go 1, 2, 3, 4, 5 places. It's making it smaller, so it's a -5. Or it's a small number, I should say, so it's a -5. This, we're going to focus on 2. So it's 2.9 times 10 to the 7th. Again, you could go, this is 10 to the 1st, 2nd, 3rd, 4th, 5th, 6th, 7th. Or sorry, 10 to the 0, 1, 2, 3, 4, 5, 6, 7, I should say. So this is the 10 to the 7th place. Or the decimal point starts here, goes 1, 2, 3, 4, 5, 6, 7 spots. It's a big number, so it's a positive 7. We're going to be going the other direction. Convert to standard notation or decimal notation. Either one of them describes our regular numbers. So if I have 5.8 times 10 to the 6th and 2.7 times 10 to the -4th, convert each of those into standard or decimal notation quick. So this one, is it going to be a large number or a small number? Large. It's a positive power. So I start out with my decimal point, and I have to move 6 spots, but I'm making this larger. So 1, I got to start adding zeros. 2, 3, 4, 5, 6. 5,800,000. Over here, large number or small number? Small. It's a negative power of 10, so it's a small number. So it's a -4, so I got to move my decimal point 4 places to make it smaller. So I got to go 1, and I'll start adding zeros. 2, 3, 4. So 0.0027.
That's 27,10,000.
Yes, correct. We can do operations with our scientific notation. Remember, when we add or subtract, we must have the same name. Scientific notation, that comes down to same power of 10. So these are both 10 to the 9th. Go ahead and add those quick. So we combine the counts. 4.8 and 8.3 make 13.1. We keep the same name, times 10 to the negative 9. Now, of course, we have to adjust that. What do we have to do? 1.31. We can only have one digit in front of the decimal point. Number got smaller, power gets bigger. Negative 9 plus 1, negative 8. Go ahead and subtract those two in your notes quick. So 7.23 minus 6.98 is 0.25. Times 10 to the 11th, we keep the same name. Now that one has to be adjusted because there isn't anything in front of the decimal point except for the 0. So I've got to move it over to make it 2.5. This time the number got larger. It went from 0.25 to 2.5. So the power has to get smaller. So it becomes 10 to the 10th. So let's say we have 3.4 times 10 to the negative 8 times 5.5 times 10 to the 13th. What are we going to do with this one? We'll do this one together. Well, it's 3.4 times 5.5, which is, what, 18.7. Times 10 to the, now when we multiply or divide, we also combine the names. So 10 to the negative 8th times 10 to the 13th is 10 to the, careful, negative 8 plus 13.
Oh, I was thinking 11.
Yep.
5.
5, very good. Now that one has to be adjusted as well. 1.87 times 10 to the 6. Number got smaller, power gets larger by 1. So 1.728 times 10 to the negative 4 divided by 2.8 times 10 to the 11th. We're going to divide 1 point, actually I didn't mean 2.8, I meant 2.4, sorry. So 1.728 times 10 to the negative 4 divided by 2.4 times 10 to the 11th. 1.728 divided by 2.4 is 0.72. Now we also divide the names. 10 to the negative 4 divided by 10 to the 11th is negative 15. Very good. Now again, this has to be adjusted. What do we have to do? Perfect. 7.2, so it becomes 10 to the, yes. Number got bigger, so it has to get smaller, so it's negative 16. Just because we haven't covered them for a few days. What do you do when you're multiplying powers of 10? Atoms, that's 10 to the 31. What do you do when you're dividing? You're going to subtract. Very good. So 10 to the 18th divided by 10 to the 7th will be 10 to the Any questions? Okay, there are some of you still working on the quiz, and that's fine. Take as much time as you need to finish up. We're going to take a look at more of what we've been doing. You know, we looked at last, what was it, Tuesday or so? Maybe, yeah, Tuesday, I believe, where we had a formula like 3a minus 2b squared over c. And we had to evaluate that for a equals 12, b equals 6, and c equals 3. So we'd have to plug those numbers in. So 3a becomes 3 times 12. We're replacing a with the 12. Minus 2 times b squared. Well, b becomes 6, so it's 2 times 6 squared. Over c is going to become 3. And now it's just a matter of following the order of operations. 3 times 12 is 36. 6 squared is 36 as well. That's 2 times 36 there. Technically, I should have done the 6 squared first. 2 times 36 is 72. So what we have here is 36 minus 72. We subtract that, it is a negative 36. So we got negative 36 divided by 3 is a negative 12. So that evaluates for those values of the variables to a negative 12. Now we saw a formula a few days ago at the beginning of class for pulleys. If I have 2 pulleys, kind of useless if I only have 1 pulley, with a belt going around it. The distance center to center of those pulleys is 18.75 inches. The diameter of this pulley, let's say it is 10.5 inches. The diameter of this pulley, let's say it is 6.25 inches. The length of the belt required to go around those pulleys. Now this is slightly approximated because there would be some trig involved if we were doing this out exactly. But the formula that describes that length, that belt, is 2 times c. Now think of that makes sense. Center to center, you've got to go center to center twice, once on each side, right? So that makes sense to have 2 times that center to center distance. So 18.75 is the c. Plus 11 times big D plus 11 times little d divided by 7. Big D is the diameter of the big pulley. Little d is the diameter of the little pulley. Now, let's separate that out. What we've done there is we've combined 2 things. It's 11 times big D over 7 and 11 times little d over 7. They've just combined them so we can divide them all at once instead of separately. But 11 over 7, if we look at that, 11 divided by 7 doesn't look significant on its own. But what if I did, instead of 11 divided by 7, what if I did 22 divided by 7? What number does that look like? That looks a lot like pi. It's really close. It's not quite. I mean, pi is 3.14159. This is 3.1428. But 22 divided by 7 is a very common approximation for pi. Well, why are they using 11 over 7 instead of 22 over 7? Well, how far around this circle do we have to go? Only about halfway, right? Does that make sense? We're only going about halfway around the circle. Circumference of a circle is pi times diameter. So this is pi times diameter divided by 2, basically. Half of the circumference. So that's what this term in this is stating, is it's half the circumference of this circle. Oops, get back there. Half the circumference of this circle, and then half the circumference of this circle. Now we have to account for the fact that, one, it goes a little bit more than halfway around this circle because it's got to wrap a little bit further so it can angle down. goes a little bit less than halfway around this circle. Also, the fact that center to center distance would be this long, and this goes at an angle, so that straight part is a little bit more than C. So the correction factor that we use looks like this. Come on. There we go. Plus big D minus little d squared over 4C. If we could actually derive that if we wanted to, it'd just take us a while, and I don't want to take the time to do it. Basically what that is a squared plus b squared equals c squared using this dimension, and the difference in the big D minus little d is the difference in the radius here. Dividing by 4 is 2 squared. And then c squared there. I mean, it works out if we did the math, but I don't want to take the time to derive the symbols. So this formula right here will give us a really, really close approximation of the length of the belt that needs to go around there. So let's plug in our numbers.
What will we call this?
This is just a formula for length of a belt. So we're going to put in 18.75 for C. So this is 2 times 18.75. I'm going to slide this over so I have my room. Plus 11 times big D is 10.5. Plus 11 times little d is 6.25 over 7. Plus big D is 10.5 minus little d is 6.25 squared over 4 times C is going to be 18.75 again. So we've got some calculator work to do here. Can't do the 2 times 18.75 quite yet. I do have to do everything on top here. I'm just going to punch that all in my calculator at once. 11 times 10.5 plus 11 times 6.25. Calculator should handle the order of operations on that piece by itself. So 184.25 over 7. Plus, again, I'm going to do the top of that. We'll do parentheses, 10.5 minus 6.25, close the parentheses and squared, gives us 18.0625. And on bottom, we've got 4 times 18.75. 75. Now, I'm going to just go ahead and punch this in the calculator straight across, partly because I know dividing by 7 is going to give us really ugly decimals. So rather than having to write numbers down and try to type them in without rounding them off too much, I'm just going to do it all at once. So I've got 2 times 18.75 plus 184.25 divided by 7 plus 18.0625 divided by 75. 64.06226. Inches. Normally, I'd probably say round to the nearest thousandth of an inch. So that would become what? 64.062. Okay. Any questions? Okay. And there are all sorts of other formulas that apply to stuff in the packet that I've given to you. Starting on Pages are sticking together here on me. Starting on page 158 and going all the way through the end of the packet on page 162. There are all sorts of formulas to apply. Some of them, they're actually asking you to create the formula, going back to what we talked to late last week of if you have, 3 times a number increased by 8, write that out in symbols. To what we just did, put the numbers in and evaluate using order of operations. So I'll give you the rest of the first hour here to work on that. You just work on the odds again. If anybody wants to check your answers, let me know. I do have the book up here for this packet that has the solutions in it.